So I have the Sigaba Cipher machine, and my name is Shelby Ross. The machine was developed in the late 1930s, but was mostly used in World War II. There were many cipher machines at the time, and that with the new technology, even stronger encryption was needed. A major contributor in cryptology was August Kirchhoff's, and he believed in less of an encryption algorithm in the work of the encryption machine, and that the emphasis should be on a cipher security, and that the argument that there should be a changed key as the main component. Sigaba used an electromechanical system of rotors to encipher, and then with security improvements over past designs, it was used by both the Army and the Navy. U.S. Army cryptologist William Friedman and his assistant Frank Rowlett started advancing the rotors and to come up with a cipher machine that was simple and easy to use, but near impossible to break. And into 1940s, joint cryptologic system was used by the Navy and Army, with the Army calling it the ECM, the Electric Cipher Machine, or the CSP-888/889, and the Army would more refer to it as the Sigaba. And it was one of the most secure cipher machines of World War II, if not the most secure. The way the Sigaba works is that it uses a series of rotors with 3 banks and 5 rotors in each. And there was the cipher rotors, the control rotors, and the index rotors. The action of the 2 banks controlled the stepping of the third, and in the first bank, known as the cipher rotors, the 5 rotors had 5, or the cipher rotors had 5 in each, and with 26 contact rotors. And when a character in plain text was entered into the Sigaba, a signal would go in one side of the bank and out the other with a new ciphertext letter. The second were the control rotors, and after receiving signals, 4 at each step, or 4 to be exact at each step, and the signal is passed through the controls, and then it's divided into 10 different groups of different sizes with 1 to 6 wires. Each group went with an input wire for the next bank of rotors. And the third is the index rotors, and it was smaller with 10 contacts, and there wasn't any stepping during this encryption process. And after going through the index rotors, 1 to 4 of 5 lines had power, and then they would turn the cipher rotors. The 10 wheels would not move during encipherment. Okay. But as far as code breaking efforts, it meant that because it was supposed to appear as more of a pseudo-random stepping, it was harder to break than the Enigma, but a lot harder to use. It was not used out in the field because of its size and price. And it was a very reliable machine. That's why it was widely used in World War II, and as far as we know, it was never broken. It was difficult to decipher, and there was just different security advancements over older models like the Enigma again that made high-level communication almost absolutely secure, even if you had the key.